In this video, we're going to discuss Gay-Lussac's law. Gay-Lussac's law is the gas law pertaining to the relationship between pressure and temperature. Here we see it's a direct proportion, which means as the pressure goes up, so does the temperature, and vice versa. If the pressure decreases, the temperature does also. P1 is the initial pressure in atmospheres, torrs, or millimeters of mercury. T1 is the temperature, initial temperature in degrees Celsius. P2, final pressure, matching units to P1. And T2 is the final temperature in degrees Celsius. So, in order to use these formulas, you must convert all your temperatures to degrees Kelvin. That means we use this formula again, where we take the temperature in Celsius and add to it 273 to get the temperature in Kelvin. Let's take a look at an example. Here we have the pressure on a confined gas started out as 285 millimeters of mercury, at which point the temperature of the gas was 22 degrees Celsius. If the pressure were to be changed to 315 millimeters of mercury, what would the Celsius temperature be then? Well, it's pressure and temperature, so I use Gay-Lussac's law. I take my given and make my assignment for my initial values, and I assign my final values, and I see that I'm looking for T2, my final temperature. So, before I can use these gas laws, I need to convert that temperature to degrees Kelvin. I do that, and then I'm ready to substitute in my values. I see again that I have to solve for T2, which is in the denominator. The easiest way to solve this problem is to take the reciprocal of both sides. That moves my T2 to the numerator, and it doesn't break any of the rules of math. Now I can isolate T2 simply by multiplying both sides by 315. This is what I got. I plug that into my calculator, and I get my final temperature is 329.4. But remember, that's degrees Kelvin. I have to change it back to Celsius. So I subtract that 273, and I end up with a temperature in Celsius of 56.4. So now let's think about this. My pressure increased, so my temperature should have also. Sure enough, sanity check shows that it did increase. Let's take a look at another example. Okay, in this example it says in a storage area where the temperature has reached 55 degrees Celsius, the pressure of oxygen in a steel cylinder is 965 torr. To what temperature Celsius would the gas have to be cooled to reduce the pressure to 850 torr? So this problem involves temperature and pressure. So it will be a Gay-Lussac law. So there's my rule. I have to find my givens. So I have my initial values, my final values. Now I see I have temperatures. Before I can make any substitutions into that gas law, I have to convert it to degrees Kelvin. So I add my 273 to my 55. Now I can substitute. Again, I see that the variable I'm solving for is in the denominator. So I'm going to take the reciprocal of both sides. Now to get T2 all by itself, I have to multiply both sides by 850. I do that, and now I have T2 equals a nice expression that I can substitute into my calculator, and I get T2 equals 288.9. But remember, that's degrees Kelvin. So I got to subtract off that 273 to get my final temperature in degrees Celsius. So my final temperature is 15.9 degrees Celsius. Let's do a sanity check. I started at 965 torr for my pressure, and it decreased to 850. So my temperature should have also decreased. Sure enough, it matches, and there you have it. I hope that this video helps you understand the Gay-Lussac law, and please don't hesitate to ask if you have questions.